Hello, I will be starting my video tutorial project. So, the question I was assigned is on the topic of calculus and specifically applied calculus in kinematics. I will start by reading the question. Richard, a Marine soldier, steps out of a stationary helicopter 1,000 meters above the ground at time t equals 0. Let his height in meters above ground be given by st. For the first 10 seconds, his velocity, vt meter per second, is given by vt equals negative 10t. In visual context, here is our helicopter, and here is Richard, and he is going to fall 1,000 meters. And it is given that for the first 10 seconds of his fall, his velocity can be defined as negative 10t, t being time in seconds. And before we solve any questions, it's important to know the relationship between displacement, velocity, and acceleration when addressing problems on the topic of kinematics. So we must know that displacement, which is s, can be turned into velocity by differentiating it, and velocity can be turned into acceleration function if we differentiate it. And we can reverse this change by integrating each of them. This will be important throughout the whole question. Now let's go to question A1. A1 says, find his acceleration at for t is smaller than 10. This equation above was the relationship of velocity, the equation of velocity for t smaller than 10. So we can, knowing this relation, we can just differentiate the function of velocity for t below 10 to get the acceleration for t below 10. This is a very simple differentiation. Using our simplify rule, we can just take out the t, which in turn will give us at equals negative 10. Beware of the unit here. Since this acceleration, it will be meter per second square. Okay, that is our answer for the first question. And then A2, it says calculate V10. This is also another simple question. You can just put 10 in the place of t in our first equation. So V10 equals negative 10, 10, which is just negative 100. Beware of the unit, it is meter per second. Now to our third part of the question. It says, show that S10 equals 500. Now, we have V, we have A, but we don't have a displacement function. So knowing this relation, we can just integrate our velocity function to get our displacement function, which we will do right now. So integration, the velocity function, negative 10t, in respect to t, dt. This is another simple integration. Knowing our simplified integration rule, just raise to the power of 1 for the variable, and with that number, bring it down, which will give us negative 10 over 2t squared. Keep note, some people might forget this, but since it's an indefinite integral, we need the plus c. Simplify it a bit, we get negative 5t squared plus c. Now the problem is we need to get c. How? This is simple. We were given a clue at the beginning. When t was 0, like at the instance Richard falls, we know that the displacement is 1,000 meters. So by putting 0 in the time of t, we can get c. In relation wise, this is negative 5 0 squared plus c equals 1,000. So c is 1,000 because this is just 0. So knowing this, we can rewrite our displacement function. St equals negative 5t squared plus 1,000. Now the question asks, show that S10 equals 500. Now it's very simple since we got the equation. put 10 in the place of t, which will give us S10 equals negative 5, 100 plus 1000, which is just 1000 minus 500, which is just 500. So we have shown that S10 equals 500. So that is question A. Okay, now to question B. Before we start question B, some information is given. It says that at t equals 10, his parachute opens and his acceleration at is subsequently given by at equals negative 10 and negative 5v for t is equal or greater than 10. Let me write down the relationship for you. So in visual context, what this means is after 500 meters, Richard opens his parachute and he, since he has a larger surface area, use his parachute. Since he has a larger surface area, will fall down slowly or have a decreased acceleration. So now let's go to our question B. Given that a dt over dv equals 1 over dv over dt, write down dt over dv in terms of v. I will write that down for you since it will be hard to know by what I say. Knowing this, the question is asking us to show this dt over dv in terms of v. To solve this question, we have to remind ourselves of the relationship between acceleration, velocity, and displacement. We know that velocity, the rate of change of velocity in terms of time, is acceleration. And that can be written as dv over dt. So we know that a equals dv over dt. And knowing this, we know that dt over dv is just 1 over a because we just switched it around. 1 over a equals dt over dv. Knowing this, we can just flip this equation and get our dt over dv. So dt over dv is just flip it, negative 10, negative 5v. For t is greater or smaller, bigger, equal or greater than 10. That is our answer for B. Fairly simple.